Okay, for wrapping up the performance and scalability section, I want to tie it back into testing and parts that you do in your software engineering process to check for different things. I mean, I've not only when I work full time in industry, but even after I came to academia, I've done a fair amount of consulting, and I often do it in the area of performance and scalability. And I go into some organizations, and I find when I ask their testing process, it's kind of the classic. There's a QA person in the corner, and he does all these functional tests, and is also responsible for the performance and scalability testing. And I asked this person, what kind of things do you do? And they go, well, we bought this load testing tool, or we're using an open source one or whatnot. There's different ones out there, and I'm just throwing a whole bunch of stuff against it and seeing what happens. This is not a rigorous, well-defined, goal-oriented approach to testing. Testing of all kinds in software engineering should be goal-driven. What are you looking for, and what kind of test inputs are you trying to construct in order to achieve those testing goals? You're looking to answer a question about the system through your testing process, your verification process. In this case, there's different kinds of tests for different kinds of goals that we might want to have. If our goal is to determine an application baseline's footprint, then we would be doing profiling. We will be looking at measuring resource consumption or response time, or whatever our measure is associated with the principal purpose or our goal. On a per page basis under ideal or unlimited resource conditions. So basically, we're trying to take away any potential bottlenecks or contention. And we're saying if this thing had the entire system and was over resourced, can I get an ideal, a typical footprint of what happens when I run this particular feature? All right, and for web application, we typically might think of it as on a per page. Could be in a per request, but a lot of times we'll think on a per page basis. Maybe if you're doing an API, it's a per endpoint basis, meaning I'm going to hit that thing repeatedly, and I want to take a look. Each request tends to take this much memory, take this much CPU cycles. All right, and I want to get that baseline, if you will, for each feature, for each component across my system at a fine grained level. And then I'll start looking at ways I commonly put them together. All right, because I'm looking to be able to later predict and identify resource contention that could happen. I mean, if I put two components together that are CPU intensive, then I would expect CPU intensive behavior. When when I integrate them and I put those two things together. Well, what if I don't get it? What if I added more threads to try and increase the throughput? And then when I wind up putting those components together into a higher order behavior, I end up with contention or a thread deadlock or a thread contention type of issue around something. My CPU level will actually drop, but my response time didn't get any better. I should know the kind of consumption I'm doing in a very white box sense by instrumenting my environment and doing very isolated profiling is very isolated traffic sent to your service to try and understand its resource consumption footprint under those idealized conditions. The opposite as a typical use test, not worrying about isolation, but actually say, here's what I typically expect the traffic to be for my web application. So I'm going to measure performance under those typical loads with a full cross section of the typical user types that I have. Right? And obviously my goal here is it's the most commonly used for response time validation. It's what I'm going to essentially baseline or benchmark against because this is what I expect to happen. Right now, the problem with that is it's difficult to use in troubleshooting because the problems are difficult to pinpoint. I'm introducing all the variables like I expect in production. So isolating something down to a particular feature, to a particular layer in the system, a particular component of the system, whatever form of isolation we're trying to talk about, right? That's when we troubleshoot, we're trying to isolate where the defect happens. And isolating that defect source can be much more difficult when I'm exercising the broad range of functionality and user types in the system. Peak use test. It's like the typical use test, except for now I'm going to be mapped to the highest expected usage scenario. So before, when I was talking about this kind of bursty nature of traffic, I'm going to take and use for peak use something close to these peaks. Sometimes I'll use 90% of the peak as an average to saying there's going to be enough times that I'm going to have to handle the peak use that I want to see how the system behaves on that peak use. I'll still have the same goals as before to validate the system and feel comfortable when it goes into production. It can handle those peaks. And again, I'll have the same problems. I'll still have a difficult time pinpointing problems. A lot of times the typical or the peak use test is constructed by going back to your load testing tool that you did the typical use test profile and adding a certain percentage, 25% more traffic, 50% more, 75% more traffic, to get to that elevated use, if you will. And a lot of times you'll even stratify like that. You'll see how it performs at these different levels, and you're looking for that lack of graceful degradation, right? As I add more traffic on a site, I expect my performance measure to gracefully degrade. If my performance measure drops off a cliff like that, whatever this inflection point is, I've got some kind of problem. I've got a bottleneck. I've got something going on in there that I need my engineers to investigate. A stress test is exercising an application beyond its maximum anticipated load, and I could even say the maximum designed for load, just to see if I do get graceful degradation or if there are breaking points. Remember, even if I have a certain load level, right? If I have my performance, I just drew a curve that looked like this. If this is on a graph of the performance measure on this axis and the load, meaning the number of requests on this axis, if I'm going and I gracefully degrade, right, I'm going to go down like this and hopefully kind of level off. And again, if I go down at some level, even if my service level agreement is, let's say, right here, and I'm obeying it, or I'm conforming to that quality of service specified in SLA, I still don't want to go beyond it and then go like that. All right, I still want to gracefully degrade and not have failure of performance whatsoever. I'd rather have degraded performance than failure. And then finally, a duration test. A duration test means exercising the application at normal or below normal usage loads, but for an extended period. We would run these things for a week at a time. And what we're looking for are resource leaks. The kind of cumulative errors that happen in the system. And yeah, that's normally a resource leak. Sometimes it is you fill up your caches. Sometimes it's you have a database connection pool leak. Sometimes it might be over time your memory does fill up, and the types of memory that you're creating is essentially a memory leak, a memory resource error, where the garbage collector cannot reclaim that memory in an efficient manner. And you're not really going to know that by running, isolated few hours or maybe overnight intense tests like 2, 3, and 4 would be, or even number 1, but only by exercising the system over a period of time to try and see if you can find things in, again, a heavily instrumented environment. Very often we would do duration tests of our profile tests, longer running versions of them, in order to see if that particular component was leaking resources. And you'd basically be instrumenting the environment to look at the hard computational resources that component would be using, or the application as a whole, and just seeing, hey, wait a minute, why is the database connection pool starting to grow and not shrink back to its normal size when we're not stressing the system? And then finally, some warnings, if you will. A common faux pas, a common bad behavior, anti-pattern, if you will, is optimization without knowing your application's behavior. I've seen, again, a lot of organizations that just kind of guess and say, oh, well, this is happening, so we have to go optimize that. We've got to throw more CPU at it. We've got to change our database connection pool. Your optimizations, just like tuning, should be data-driven. Which means you should have an experimentation type of mentality in your organization, as well as be consistently reviewing your application's logs, what kind of features are being used, and cross-reference those with the computational footprint, the computational consumption that you're seeing in your production environment. And then follow the 20/80 rule, right? Optimize the 20% of the application, or maybe it's the 5%, that's causing 80% of your performance problems. Go search for those bottlenecks first and solve those kinds of things first, and don't spend your time optimizing things that are edge cases, if you will. So finally, a top 5 list of my recommendations for performance and scalability testing. First, do it early as part of analysis. Each developer should know to performance test her or his application components. In particular, developers should be able to profile the components that they're working on. And if they do a change, there should be, just like there's a small unit test, should be a small performance and scalability test, so you understand if you fundamentally change the resource profile of that component you're working on. Do it early as part of iterative development. Dev teams should do it as part of iteration closeout activities. You're running a sprint. You have, I don't care if it's a 30-day sprint, a 2-week sprint, but you should checkpoint against a baseline, even with inside the development team for doing that. When you test, know your testing goal. Knowing your goals here. I mean, it's amazing how many folks do testing as a kind of check the box activity. Knowing what the goal is and what the question is that you're looking for is much more efficient than saying, I'm just going to run a test and look at the results and see if anything looks kind of weird. You want to have a goal. You want to have a question answered about the system. So if you know your testing goal, if you know it's for idealized use, if you know it's for a production benchmark or whatnot, it's going to affect what you do and how you interpret the results. Invest time in performance and scalability testing infrastructure across your organization. Have common tools, common scripts, code instrumentation, test data repositories. When we talk about infrastructure automation and continuous delivery and continuous deployment and continuous star type of behaviors in an organization, it means you need a heavily monitored and heavily instrumented environment in order to do this well, which means you have to invest in it. It takes time, it takes money, it takes tools in order to be able to pull off this kind of thing well. And then finally, create benchmarks and use them in regression tests. QA organizations are traditionally reasonably good at doing a functional regression test, understanding what features have changed, rerunning to make sure that changes to some features didn't incidentally change some other features elsewhere in the system. Well, that's even more likely to happen in performance and scalability way, because some component that we change may now start consuming resources, and there may be no functional coupling or connection to some other component other than we map them onto the same computational resources, and that now they're in competition because of something about their profiles have changed. That's a very indirect form of coupling, if you will. And I'll only know that if I do a performance and scalability regression test, which means I have to have those benchmarks, those established baselines internally to compare against, and to say, wait a minute, okay, we have a new release, we have all these new features, that's great, but why are pages 2 seconds slower to load? Why are we using that many more database connections? And there's something from an infrastructure instrumentation perspective or an infrastructure build out perspective that I need to change. So testing is always, verification of a system is always a very disciplined process, and I often find that performance and scalability lacks rigor in a lot of organizations because it's underserved, because it's not this necessarily functionally driven observable behaviors. Hey, something's on the screen, it works. It's very important to understand when you put that thing out in production, you don't want the beepers going off. You want that thing to perform, you want it to scale, you want it to run smoothly for a long period of time. So that's it for performance and scalability, one of my favorite topics, one of those really practical topics. It is not enough just to write a web application that works on my laptop, works on my dev station. You've got to be prepared to write web applications that will work for hundreds, thousands, tens of thousands, millions of users on whatever infrastructure you provide, from both a coding perspective, a software engineering perspective, and an infrastructure systems engineering IT perspective.